When we think about AI security, we usually picture hackers trying to break in from the outside, right? But what if the biggest vulnerability isn't something trying to get in, but a weakness that's already baked into the AI's brain? Today, we're going to look at how to secure AI from the inside out. So here's the big question that bugs a lot of us. You've got these super smart AI models. Think malware detectors, fraud prevention systems, trained on just millions and millions of threats. And yet, some attacker can just slightly tweak an email or create a piece of polymorphic malware and it sails right through. How on earth does that happen? And the answer is, honestly, kind of wild. It's not a bug in the code. The problem isn't in the AI's logic at all. It's in its education. The very data we use to train the model has these hidden flaws, and that creates what's known as the brittle AI problem. So yeah, that's what we're talking about today, the brittle AI problem. Where a model looks like a genius in the lab, but just completely falls apart the second it sees something new. So how do we fix that? How do we make it tougher? Well, the first step is a really cool technique called data augmentation. All right, so let's talk about data augmentation. Honestly, the best way to think about it is like a personal trainer for your AI. Instead of just showing it the same few examples over and over again, you're constantly creating new, modified versions. You might slightly change a phishing email or generate a totally new kind of threat log. The whole point is to build a tougher, more resilient model that doesn't get blindsided by the unexpected. And you know what? This whole idea might sound really familiar if you're a cybersecurity pro. It's basically the AI version of red teaming. A red team, they simulate attacks to find weak spots in your defenses. Well, data augmentation does the exact same thing for an AI, simulating all these different variations of attack data to really broaden the model's understanding of what a threat actually looks like. We can even take that comparison one step further and think about it like fuzzing, right? In software security, you just bombard a program with tons of random, weird inputs to see what makes it break. Augmentation is pretty much fuzzing your training data. You're stress testing the model with all these variations to make it way more robust against the chaos of the real world. Okay, so why do all this? What's the real security payoff here? Well, the benefits are huge. Augmentation makes your models way more resistant to things like evasion and spoofing. It also stops something called overfitting, which is basically when a model just memorizes the training data instead of actually learning the patterns. By stopping that, it helps the AI generalize and handle brand new threats it's never seen before. It's fundamental to building a model that can actually survive out there. But look, making a model tough is only half the puzzle. What happens when the most dangerous threats are also the rarest ones? Because if we're not careful, the AI can literally be trained to just ignore them. And that right there is the unseen threat problem. And this is where our second technique, data balancing, comes in. So imagine you're training an AI to spot insider threats, right? 99.9% of what your employees do is totally normal, totally benign. If you just feed that data straight to the AI, it'll learn a very simple, very wrong lesson. Just label everything is safe. It'll get a fantastic accuracy score, but it'll miss the one critical malicious event you actually care about. Balancing fixes this. It makes sure that those rare but super critical categories, like insider threat, get the attention they deserve during training. And again, this has a perfect parallel in the world of cybersecurity ops, tuning your intrusion detection system. If an IDS isn't tuned right, it's just going to ignore those low and slow attacks, creating really dangerous false negatives. Data balancing is pretty much the AI version of that tuning process. It ensures those quiet but deadly threats get enough airtime during training so the model actually learns to recognize them. Or think about it like event weighting in a SIEM. A good analyst knows that a single failed admin login is way more important than 1,000 successful web requests, right? So they assign a higher weight, a higher priority to that critical alert. Data balancing does the exact same thing for the AI. It statistically boosts the importance of those rare events, so they don't just get drowned out by all the noise. So at the end of the day, data balancing is what lets your AI find that needle in a giant haystack. It's absolutely essential for spotting those rare attacks. It stops attackers from just hiding in a flood of benign data, and it's a critical tool for making sure your model is fair and unbiased. Okay, so we've got these two really powerful techniques, right? Augmentation for making the model tough, and balancing for making it sensitive. But where they become truly game-changing is when you use them together. And this table just lays it out perfectly. It shows you the power of this duo. You want to reduce bias and make the model more robust? You need both. Want to improve resilience against adversarial attacks? Augmentation is the big player, but balancing definitely helps. But when you're talking about detecting those super rare cyber threats, balancing is the clear winner there. They're not competing with each other. They're these complementary forces that work together to create a really secure AI foundation. And that really brings us to the main point of all this. Data augmentation and balancing, these aren't just little nice-to-have tuning steps you do at the end. They are a foundational security control. And we are not talking about some abstract academic concepts here. This stuff is essential for the critical AI systems we all depend on every single day for our security. We're talking threat detection engines, malware classifiers, fraud detection systems, even the automation running in your SOC. Every single one of these is fundamentally broken if it's built on bad data.
So I want you to just let this sink in for a second. This quote really says it all. Poorly balanced or unaugmented datasets create security vulnerabilities inside the AI itself. The threat isn't just coming from the outside, it can be baked right into the model's DNA from day one.
And that leaves us with a really critical question we all need to be asking. As we build and rely on these incredibly powerful AI systems, we have to wonder, is our AI's biggest vulnerability its own data?